All right, so my board is not calibrated. All right, so we're going to do some notes. You should have grabbed it on the way in. If not, make sure you grab it. It's arcs and angles, right? So this is our third day in our circles unit. On 5.8, we were talking about properties of tangents. On 5.9, we were talking about central angles. That was yesterday. Who was not here yesterday? So if you were not here yesterday, make sure you get yesterday's notes and assignment in the blue bin in the back. Okay? So we are still in circles. Circles are cool because fidget spinners are cool. And SpongeBob and Captain America, right? Relevance. So let's do some notes on arcs and angles. So it says angles inside the circle theorem. Now we've talked about central angles. That was yesterday. But we are not talking about central angles today. They're just angles somewhere inside of the circle. So, if two chords, right? Two chords. Y'all know what a chord is from Tuesday? It's a segment inside of a circle from edge to edge. Let's have our heads up as we work. All right, so if two chords blank inside a circle intersect inside of a circle, then the measure of each angle is half the sum. Now what does sum mean? S-U-M. Sum means I do what with two numbers? I add them, okay? Sum, add. So, check it out. I have an example right here. If I'm looking for angle 1, then I'm going to find the sum of these arcs, AB and DC. Let's write in DC right here. And I'm going to put a half in front of it once I add them up. Okay? You might remember the phrase average. We're basically averaging the two arcs to get the angle on the inside. So an interior or an inside angle, right? So, look at example 1. Now, we're going to start with the harder problem, okay? So, it gets easier from here. So, if you get freaked out about this problem, they're not all like that. They're not all this hard, okay? But this one's kind of challenging. So, let me show you why, okay? It tells me to find Z, but Z is one of the missing arcs, okay? So, it's a lot easier if the missing variable is in the middle, but it's not. So, check it out. I have this arc, and I have this arc. Now, the sum of those, half of the sum of those is supposed to be between them. So I want everyone to look right here. Is 1/16 between those two arcs? And what I mean by that is it the angle exactly between them? So as you can see in my little dotted line, 1/16 is not the angle between them. Okay? Like, if you look at number 2, do you see how 50 is between them? Okay, that's what you want. So we have a problem with our first one. So that's why this one's a little bit more complicated, because people get confused and they use 1/16. So instead of using 1/16, we need to figure out this missing angle right here. That's the angle I need. So what do we know about a straight line? How many degrees is this straight line right here? 180. So to figure out that missing angle, I'm going to do 180 minus 1/16. What is that? 64. All right. So I'm going to write that in right here. I care about 64, 1/16, nah. Okay? So here's what we're going to do. Every time you do one of these problems with an angle on the inside, you're going to first write the angle. So what's the angle we just found? 64. Okay, start with the angle. Then you put equals. Okay, I'm just following this right up here. So now I'm going to put this 1/2, then a parentheses, and now you're going to add your two arcs. Okay, so what are my two arcs? What is this? Z, and what is this? 44. So Z plus 44. Okay? Cool. Now, this is a weird situation. The Z that I need to find is in a parentheses with a half in front of it. Aren't fractions less fun to work with? So if you have a fraction you need to get rid of, my suggestion is to get rid of that fraction first. Okay? Some of us need to put pens or pencils in our hands, have our eyes wide open, because the notes are not on your eyelids. I didn't write them there. I don't have that superpower. But that would be a cool superpower, right? Right? Wake up! All right, so let's solve this. How do I get rid of a 1/2? What's the opposite of 1/2? Multiplying by 2. Very good. Y'all are so smart. So again, multiplying by a half is like multiplying by its reciprocal 2/1, which is 2. So check it out. Times 2 will cancel out the half. You need to know that today. Anytime you're trying to eliminate or get rid of a 1/2, you're going to multiply by 2. Okay? So if I do it on the right side, I'm going to do it on the left side. What is 64 times 2? 128. Bring down Z plus 44. Now this should be an easy one-step problem. How do I get rid of the plus 44 on the right side? The opposite, the inverse operation of plus 44 is minus 44. Very good. So, what is 128 minus 44? 84? True. Very good. Now, I'm admitting to you, that is the hardest type of problem for inside angles, but let's do one that's a little easier. A little bit, okay? Well, I'm just saying that's the harder one, so if it gets easier, then yay. Those easier ones will be less steps. Let's try that. So, little divider. On this next one, is 50 between the two arcs that I'm using? Yes. Yay. So I'm going to be able to use 50. I don't have to do what I did over here, right? Don't need to do that. Okay, so let's set it up the way we learned how to set it up. I start with what? Angle or arcs? Angle. So the angle on the inside is 50 equal sign 1/2 parentheses, and now I'm going to add my two arcs, T and 40, right? T plus 40. Now, when we have a quiz on this next week, and we refuse to do what Mr. G says, and we tend to be getting these good grades lately, I'm very skeptical. I might have to pull a fast one on you, see if you're actually doing your own work, right? But everyone's going to get great grades. So let's do this. What do I do to get rid of that 1/2? Times 2. 50 times 2? So yes, 100 equals T plus 40. Last step, to get rid of the plus 40. Okay, subtract 40, and what do we get? Close 60. Is that what you said? It should be 60. Yeah, it's all good. Okay, number 3. All right, number 3. Again, what's the angle? So, sorry, the angle on the inside, R, equal sign, 1/2, parentheses, and then these two arcs we add together, 96 plus 102. Now this time you don't have to get rid of the 1/2 because the variable is not inside the parentheses, so you can add them up and then multiply by 1/2. So, what is 96 plus 102? 198. Okay, let's write that down. 1/2 times 198. And then, what do I get? What is it? Yeah, but times a half. Is it 99? All right, good. 99. Okay, so on your assignment, when you get to stuff like this, you got examples you can use. Let's try at the bottom here. What if the angles are on the outside? It's going to be very similar, but instead of adding, we'll see here. All right, so if you have a tangent and secant, two tangents, or two secants, basically look at these three pictures. Anything that makes an angle on the outside, okay, then the measure of the angle formed is blank, the blank. Okay, so once again, it's going to be half, but this time it's going to be the difference. Does everyone know difference means subtraction? Difference means subtraction, right? So let's try that. Let's fill this in real quick. This angle is half of BC minus AC. Two tangents. This one is the major arc PQR minus the minor arc PR. Half. And then over here, XY minus the minor, smaller one, WZ. Okay? So that was a quick fill in. You can flip it over because we're going to try the examples on the back now. There you go. Put it away. So on the back side, we're doing example 1. Right? So on example 1, we want to identify our two arcs that we're using. So what are the two arcs that we're using? Okay, so the bigger one over here, 161. The smaller one is 67. So here's how we set it up. The angle on the outside, x, equals 1/2, parentheses, and this time we're subtracting big arc minus small arc. 161 minus 67. Okay? The only difference is subtraction. So let's do that. What is 161 minus 67? Okay. 94. And then what is half of 94? 47. Cool. Now, easy or hard? That one's an easier one because they gave us both arcs. So all we had to do was subtract and divide by 2, or multiply by 1/2. Let's try example 2. So I need to identify what are my two arcs. So I have this big major arc right here, 238. Here's the question. What is my smaller arc? We don't know what it is. It's not necessarily half. But here's something we do know. Since those are two tangent lines, those two arcs make a full circle. How many degrees is a full circle? 360. So to figure out the missing arc, I'm going to take what I know, subtract it from 360. So off to the side, 360 minus 238 gives us 122. Let's write that right here. Now, that's not the answer. That'll help us get the answer. So we're going to do it the same way we just did. What's the outside angle? X equal sign 1/2 parentheses, and then 238 minus 122. Outside angle, subtract. Inside angle, add. Those are the differences. What's 238 minus 122? Okay. So what's 1/2 of 116? 58 degrees. Now this is where it gets a little tricky because we know the outside angle is 35. So let's set it up the exact same way. Angle, 35, equal sign, 1/2, parentheses, and the bigger arc minus the smaller arc. 95 minus x. Okay? So this is a situation where I need to get rid of that half, right, to get to that x. So how do I get rid of 1/2 again? Times 2. Cancel, cancel. Times 2. 35 times 2 is 70. Bring down 95 minus x. Now this is kind of tricky, because how do I get rid of, or what should I do first? So I want to hear what y'all think. What do you think? Okay, so we are going to subtract 9, the way I like to do it. Subtract 95, even though it's going to be kind of ugly. Minus 95 gives me negative 15 equals negative x. Which almost looks like it's done, but it's not, so that negative sign's got to go. Now, pro tip, if you've got a negative on both sides, you can kind of eliminate them both. They're just both gone. Because what you are doing is dividing by -1 on both sides. Divide by -1, cancel. Divide by -1, cancel. So you're left with x equals 15. Okay. I did that first period too. 25 is what I should have said. I got rusty mental math. Sorry. 25 is the answer, not 15. Okay? I'm on record. It's a goof up. All right. Now, so again, that's 25. Make sure that's written right. Mavi. Now, inscribed angle. This is the last one. So on the front side, we did inside angle. We just did outside angle. But what if it's on the circle? This is called an inscribed angle. What do we do with an inscribed angle? Well, an angle whose vertex, does everyone see this vertex, is on the circle, and whose sides contain arcs of the circle. Okay. Now, this angle, DEF, is inscribed from D to E to F. It touches on the circle, right? Kind of looks like a Pac-Man. Kind of. So, inscribed angle theorem says the measure of the inscribed angle is half. So you don't have to add or subtract this time. It's just half. That's it. Okay? The inscribed angle equals half of the intercepted arc. Okay? So these can be easier as long as you don't get confused. So let me show you what I mean. What is the inscribed angle here? Angle ABC, or angle B. It's supposed to equal literally just half of what? The intercepted arc is 120. What is half of 120? Mental math. Inscribed angles can be the easiest ones, but they can be confusing if you get them mixed up. So look at example 2. How is this different? Right, so we know the angle, so I'm going to put the angle first. 35 equals 1/2, and this time I'm missing arc DF right here. So arc DF, and that's supposed to be an F. Thank you. All right, now how do I get rid of the half? We've been doing this all day. Times 2. So times 2, cancel, cancel. Times 2, 35 times 2. So don't always just randomly divide it, okay? This one was backwards. You got to multiply it. See the difference? What should we do on example 3? Angle ABC is the angle. That equals half of the arc, which is 60. So what's my answer here on example 3? 30. Okay? So, 3 types of problems. Inside, outside, on. So, as usual, okay, you can kind of separate your notes from your assignment, but I'll give you some pro tips, okay? So, the very first thing we did, inside angles. If you want to know which ones are like the first part of the notes, that would be numbers 1, and then you flip it over, 9, 10, and 11. So, inside is numbers 1, 9, 10, and 11. If you want to do all the same type of problems that are going to be, adding and then dividing by 2, you know, that's how you do 1, 9, and 10. Okay? 1, 9, 10, 11. What about outside? So which ones are on the outside? Well, those are all on the front page, and that's numbers 2 through 8. So number 2 through 8, that's the ones you're going to subtract and do half, right? And on the circle, inscribed angles, I'm looking at it on the back side, that's 12 through 16. That's just half, right? So again, these ones you add and then half, these you subtract and then half. Okay, so these are inside, outside, and on means inscribed, right? So that's just some tips, but you can do it based on those notes. I have faith in you. 8 might be a little weird, just make sure you label it and you'll be all right. Let's go ahead and get started.